Go. This is a practice problem for net ionic equations, and the question is, what is the net ionic equation of the reaction Na3PO4AQ plus 3AgNO3AQ yields 3NaNO3AQ plus Ag3PO4S? In order to do that, I've rewritten the equation down here. And when you do net ionic equations, what you're essentially doing is you're taking all of these four compounds and you're going to be splitting them up into the individual elements or their polyatomic ions. And when you do that, you're going to take the subscripts of the individual elements, such as sodium here, and draw them out to the front. Or in the case of polyatomic, you're going to leave the subscripts there. And for all of them, what you're going to do is you're going to draw the charges of either the element itself or the polyatomic ion with the ion, and you're keeping the phase notation in there as well. So to demonstrate this, you're going to need a periodic table. And so first you have sodium. And so what you're going to do is you're going to take out this 3 here. You're going to put it in front of the sodium. So it's going to be 3Na. You're keeping the phase notation, so AQ. And the charge of sodium, looking here, is going to be +1. So I'm just going to draw a plus here. And now I put a plus over here. And PO4 is polyatomic. It's phosphate. So I'm writing PO4AQ. I'm keeping that subscript in its place. And the charge of phosphate is -3. Now moving on to the next compound, Ag, it's by itself. Now here, I know that the charge of, well, this is silver. So the charge of that is going to be only 1. So I'm just going to do a plus, keeping the phase notation. And I'm keeping this coefficient here as well. So I'm just going to keep that down here because this needs to be balanced still. And so now with this polyatomic ion, it's going to be a bit more difficult because you have a coefficient here, but you also have the subscript here. And so all that you end up doing is you end up keeping the coefficient, and you're going to keep that polyatomic ion as well. So it just becomes 3NO3. You're keeping that subscript and the coefficient as well. It's still AQ. And the charge of NO3, or nitrate, is -1. So I'm just going to put minus. And now I can draw my arrow. Moving on to the next half, I have sodium again. I'm still just keeping that coefficient. 3Na. It's also part of an aqueous solution, so AQ plus 3NO3 AQ minus, same as before. Now, when you reach your solid compound, this one with the S over here, you're not going to split it up because it's not aqueous like the rest of them. It doesn't split. This is your precipitate, so you don't want to split it up here. So you're just going to leave it as Ag3PO4S. And now you have to find which one of these are your spectator ions. Everything that is not in this final solid compound is going to be a spectator ion. So if you look at the first half of the reaction, this total equation here, you have to cancel out everything that is not in this solid compound. So sodium is not in it, so I can just cross it out on both sides of the equation. Nor is nitrate, so I can just cross that out as well. So what I'm finally left with is PO4 and Ag. So I'm just going to rewrite that down here with the charges still. 4AQ, keeping the phase notation as well, plus AgAQ. And I'm going to leave the subscripts out of it for now until I realize whether or not I need to balance this later. O4S, and there's no charge on this because it is an ionic compound. And so now looking at this, I'm on to balancing, and I see that there's only one PO4, but there are 3 silvers here. So I need to put a 3 right here, and now it's balanced, and this is your final net ionic equation.